Let's take a look at another example of where we're using U substitution to find the antiderivative of a slightly complex function, but one that we can express in terms of a much simpler function. So this time we've got the indefinite integral of 2 times sine of 2x plus 3 dx. So I'm going to start off by defining a u where that substitution is going to make this a lot prettier. I'm going to have a really simple function in terms of u instead of this slightly complex one in terms of x. All right, and so what I want to do is I want to use the entire inside function here. So it's 2x plus 3. Notice that if I let u equal 2x and substitute this in, I would still be trying to find the antiderivative of sine of u plus 3. And the sine of u plus 3 doesn't show up in integral tables. So I want to use this entire inside function. So this is just going to become sine of u after I do the substitution. And with that in place, taking kind of the differential of both sides, so 2x is going to become 2 dx. 3 is a constant term, and so that's just going to vanish. So once again, I'm not going to rearrange it like I did in the previous problem, but sine of 2x plus 3 becomes sine of u. And then that leaves me with the 2 and the dx. And 2 times dx is equal to du. So this is a function where I can very easily take the antiderivative. What is the antiderivative of sine u? Careful, it's negative cosine of u. And you also have to remember to always add a constant when you're taking the indefinite integral. All right, and the last step is going to be substituting 2x plus 3 back in for u. So this is negative cosine of 2x plus 3 plus c. All right. The next problem is going to have a little bit of a wrinkle in it. So you can go ahead and give it a shot and see how far you can get into it. See if you can find where things are kind of veering off track a little bit compared to the first two problems, and see if you can figure out how to work around that. And if you can't, at least you'll have gotten far enough that you've gotten your practice in, and you can see how we tackle it together in the next video.